Hello there. As you can tell, we have a couple of changes. First of all, you can see me. So, hi, nice to meet you. Second is I've now got a cheat sheet on my side, which shows the points that I'll be addressing during the video. So hopefully this way I'll be able to get through content that will be in the video faster without as many ums and ams and so forth. Let's get started. So today's video is about structs. Structs stands for structures, and if you're familiar with object-oriented programming, it's pretty much the variables that you instantiate, the instance variables in your object-oriented programming class or object. Okay. So to start off, let's create a struct. Creating structs. The syntax for creating structs is pretty simple. What we do is we call a struct. For demonstration, I'll be creating a rectangle struct, then curly brackets, and inside of the struct, you're going to say what kind of variables you would say in an object-oriented programming. Just the same as you would. So right here, you can have a width for the rectangle. That's going to be a U32, and we can have a height, and that's going to be a U32. Okay, so that's how you create a struct. Now, next, how do we instantiate a struct? Instantiating structs. Hopefully I spelled that right. To instantiate a struct, we would create, just as usual, normal variables. We say let rect equals rectangle, and we would then say the values that we're gonna give to this one variable that's an instantiation of the structure. Let's say 10, and height, let's say 50. Okay. Right now there's not much to see because as it is now, we can't really print this rectangle. We'll get to that later, but what I want to show you now is how you can access struct elements. Okay. The way that we access struct elements is pretty intuitive, I would say. Let's create a print line. Let's say accessing element, height, and as you can guess, we'll say rectangle dot height. Okay, so right now we can run the program for the first time. Hopefully we won't get any errors. And there we go, accessing element height gave us 50. Okay. Right now, if I wanted to change, so change struct elements, well, first of all, I'll have to make them mutable, because as always, they're immutable by default. And what I will do right here is I would say rectangle dot height is equals to 60. Let's come here, copy that, accessing element height. Let's say post change. If we run it, we see that the element height post change is now 60. Okay. Now, next thing we'll talk about is nameless structs, which are actually called tuple structs. What that means is that we're creating a struct without naming each of its variables. And that's useful in a couple scenarios. The example I'll give you is color. You can create a struct color and then just say U32, U32, and U32. Okay. Notice the difference in syntax. Right here we're using normal parentheses rather than curly brackets. And to instantiate that struct, we'll just say an RGB is equal to color. Let's say black is equal to color 0, 0, 0. Okay, so, and that works just fine. And to access something in a tuple struct, let's say t struct, we do, it's also pretty intuitive. You can pause the video and guess if you'd like. But what we do is the element in t struct, we say black.1, just like we did in tuples. Okay, so we kind of derive that same syntax. So right now, if we run it, we'll get 0. Okay, so these are tuple structs. Moving forward, let's talk about printing structs, which is what I mentioned in the beginning of the video. To print a struct, first I want to introduce you to something that I've been using in the past couple of videos, but I didn't quite describe what it means. Whenever I did this to print something like an array, and whenever I did this to print whatever, I was making use of traits that these two, well, whatever an array have. In this case, I was making use of the trait called display. And in this case, I'm making use of a trait called debug. Okay. So our rectangle right now doesn't have any of those traits. We just created the structure, right? So it doesn't have debug and it doesn't have display. Actually, I can show you how that shows up in the console. If we try to come here and print a rectangle, and then run it, we'll see that the trait display is not implemented in rectangle. Okay. And it even tells us you may be able to use this or that for prettier use. So let's try it. If we do this, you'll see the trait debug is not implemented in rectangle, right? So what we want to do is we want to kind of borrow this trait for rectangle. And the syntax for that is we use this, and we use the word derive, not borrow, and we say debug. Okay, so what I'm doing right here, I'm deriving debug, which will allow us to print like this. So if I run it right now, you see that we get the rectangle printed. What I mentioned previously about making it prettier is if we add this pound sign or hashtag and we run it, you see that it formats it a bit nicely, which if you have larger structs is super useful. Okay, now another thing I want to talk about is a couple of shorthand uses that you can have for structs. They're quite useful. So the first one is copying values from other structs. Okay, so let's create a second rectangle. I'm going to call it rectangle 1. I'm going to say rectangle. Let's say rectangle width is equals to 1. And then I want to keep the same height, but I want to come here and say height rect dot height. Okay, I'm too lazy to do this, and if I had more elements, this would be incredibly annoying. So something that Rust allows us to do is do dot dot and then rect. What this means is whatever is before, we set these values. Whatever is the rest, we set these values. Okay, so if I come here right now and I print my rectangle 1, you see that we have 1 and then 60. So it derived, I guess, the value from this other rectangle. All right. so the next shorthand that I want to show you is with functions. Okay, so I'm going to create a function that's going to say new rectangle, and in here I'm going to pass in width, which is going to be a U32, and I'm going to pass in height, which is going to be a U32. Okay, we're going to output a rectangle, and in this function we're just going to create a rectangle. And right now what Rust allows us to do is, instead of saying width equals width and height equals height, if the parameters passed to the function have the same value as the elements, we can simply say width and height. Okay, so hopefully we don't have any errors here. Oh, can I find rectangle in the scope? Of course. Let's move this function inside, because rectangle is within the scope of main. If I put the struct outside of main, we would have been able to see it, but I did not. So right now it should be just complaining that it's dead code. Yeah. And so right here, if I say let's create our third rectangle, rectangle 2, new rect, I can then say 1, or rather 60 and 1. Okay. Once again, let's make use of our derived debug trait and print a rectangle 2, and we get 60 and 1. And we use the function and the shorthand notation for initializing the rectangle. Alright, this was part 1 of the video. Now let's get into methods. What methods are, they're pretty much functions, but defined within the context of a struct. Okay, so suppose that I wanted to have a function that calculates the area of a rectangle. And to do that, just so we can access the rectangle outside of main, I'm going to copy this struct, and I'm going to put it right here. Okay. Let me copy this. There we go. So here, create the struct, all right. And so if I can create a function here, let's call it area, and we're going to pass into a rectangle, and we're going to output a U32. So, oops, sorry, rectangle, rectangle. So right now what we'll do is we'll get the width, we'll get the height, and we'll return it, right? So right here I should be able to do let dot, oops, what do I mean? Print line, and I want to show that we're calculating the area properly, so I'm just going to call area. I'm going to pass in rectangle 2. So this should output 60, right? I'm going to say area. If we run it, we get 60. All right. What methods allows us to do is they allow us to show in the code that there's a clear relation between a certain function and a certain structure by tying them together. And this act of tying them together, by this act of tying them together, we decided to change the name and call it a method in Rust. So what that means is that we're not going to have this function area. We're instead going to create an implementation, spelled IMPL, of rectangle, and inside of here we're going to create the function area. And now this is important syntax. We're going to pass into area self. What this means is that we're passing into whoever is calling the function. So in here we will do something like rectangle.area. The self will get this. Okay. So we'll do self and we'll return a U32 again. In here we'll do self width times self.height. And we're returning this value. Now what we can do, so let's grab this again. We can say rectangle.area and print it. Ta-da! 60. Okay, so these are methods. This is a normal method that you can implement. Right now, let's do something a little bit different. I want to use can hold, and in this case, I'm going to pass in self, but I'm also going to pass in a second parameter. Okay, and the second parameter is going to be a reference, not a reference, sorry, a reference to a rectangle, and we're going to output a boolean. What I want to see here is I want to see if a rectangle can fit within a rectangle without any rotations. So if I have a rectangle that's 10 by 10, so a square, a rectangle that's 5 by 5 would fit inside of the 10 by 10. So I just want to check if we have an error here. I guess maybe it's because we're not returning anything yet. Oh no, because I forgot to say rectangle again. Well, okay. Right now, I'm going to get self.width has to be higher than rectangle.width, and our self.height has to be higher than our rectangle.height. Okay. Now let's see something that will fit into the other one. What's our first rectangle? Our first rectangle is a 10 by 50. Our second rectangle is a 1 by 60. Nothing really fits into anything. Let's make this third rectangle a 5 by 30, just so we can fit 5 by 25. So just so it can fit in the first rectangle, rectangle 0, I suppose. And let's call print. We'll say does fit into actually does. I'm just gonna say rect1 fit into rect. Sorry, does rect2 fit into rect0? Yeah. And we're gonna pass that in. Okay. Now what I'm gonna say is I'm gonna say rect dot can hold. I'm gonna pass in a reference because we don't want the can hold to own the rectangle. We just want it to use in the calculation. And we're gonna pass in the reference to rectangle 2. Okay. So we shouldn't have any errors. And if we run it, we do have errors. Expected type. Oh, no, I forgot to say that we want to use the reference to the rectangle width and the rectangle height. And if we run, we get that rectangle 2 fits into rectangle 0. Okay. Now, probably the last thing I want to show you is associative functions. And associative functions, they're just functions that we create inside of a struct that don't pass into self. So suppose that I wanted to create a function called square, which will create a square rectangle. And I'm not passing into self, I'm just passing into the size U32. And we're going to return a rectangle. Okay. Right here, what I'm going to do is I'm going to create a new rectangle with width equals to size and height equals to size. Now, the way that we call this function, because we don't want to associate it with rectangle 1 or rectangle 2 or rectangle 3, similar to what we do with static functions in object-oriented programming, is we just say, let's create the square, and we say rectangle colon, not main, sorry, square. And let's say I want to create a square by size 10. Now let's print our square. And we get the rectangle of width 10 and height 10. Right, so these are associative functions. And a little side note I forgot to mention. Something that Rust also allows us to do is it allows us to make several implementations of rectangle. So if I wanted to, I could get this associative function and I could move it right here. Okay, and this is fine. This is absolutely fine. I can run the code and we get the exact same result. So you can have several implementations, and this is useful in something that we'll see later on with generics and whatnot. So yeah, well, I think this is it for now. I hope you enjoyed the video. Let me know if you think the camera is necessary, or if you'd liked seeing someone speak, or if not, how is this style of code? Just code along, or if you have the resumes, not the resumes, the summaries. And yeah, I think that's about it. Thanks so much for watching. I'll see you next time, and bye.